Hello again, everybody. This time we're going to stop talking about water, but not really. And this time we're going to talk about pH. So if you remember from middle school, maybe not, your pH is just a measure. It's something that we can talk about solutions with. It's a measure specifically of how much H+, how much of this ion there is inside a given solution. So if you remember anything where you were mixing two items together, water plus sugar and so on and so forth, inside here, you'll see that there's water, and inside you'll see there's a whole bunch of H+ or other things that are not H+. So for example, H+, H-, and so on and so forth. We don't care what the other thing is. What we care about is how much of this ion is floating around inside. Now, we can measure that using some fancy schmancy science. Fancy science. We don't care about that. What we in Miss School's biology class care about is your pH scale. So on a scale, where we measure from 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 13, 14. From 0 to 14. This is the pH scale. I apologize for not drawing it directly centered, but this is my pH scale. So however much H+ you have tells you where along this scale you fall. You're given a number. Now, if you have low H+, you are going to be at this end of the spectrum. Now, if you have high H+, you are going to be at this end of the spectrum. Anything that is below 7, so 7 right here is like our middle marker. In a normal math number line, 7 is kind of like your 0, where it's not positive, it's not negative, it's not, any number that isn't 0, right? This is going to be our neutral. So our 7 is going to be neutral. So the only thing in the entire universe that we care about that is neutral is water. Pure H2O. This is all that we care about, the only thing that is neutral. You should not give me anything besides water. Okay, now on either side of this water, on 0 through 6.999 and so on and so forth, we call these acids. And on this side, from 7.000001 to 14 and above, anything bigger than 7, we call these bases. Now, because 7 is neutral, because 7 is the normal, nothing's happening at 7, we can compare the numbers to tell us how strong something is. So the farther away you are from 7, the stronger you are going to be. So on this end, closer to 0 is strong, and on this end, closer to 14 is also strong. That means this area right around 7 is going to be weak, with the exception of 7, which is very neutral. So if we were to actually use these words, we might say that, for example, around here, 5. This is close to 7, so the pH 5 might be a weak solution, because it's weak, it's close to 7, and because it's less than 7, it is also an acid. Now, if something were at the 14 end, something that has pH of 14, because it's a far away from 7, we say this is a strong solution. And it's also on this end, so we call it a base. So something like pH 14 is a strong base, something like pH 5 is a weak acid. The only thing that is neutral is 7. Okay, so now we talk about pHs. Great, that's amazing. The last thing you need to know about pHs and everything pH is that as humans, as humans, human beings, we are somewhere around here. Human beings are somewhere around here on average. Around 7.4, 7.5, 7.6, somewhere in that range depending on the person. We humans can't be stronger than that. On either way, we can't be more acidic, we can't be more basic, because then we are going to shut down and we are going to die. So to prevent this from happening, we have something in our bodies and also in other chemical situations, something called a buffer, which is just some chemical that can prevent that prevents changes in pH. So it's going to try and keep the same. So it's trying to keep the same pH. Keep same pH. So if we have something at 7.5, our buffer is going to keep us within this small range so we don't go way out onto the base side or way over in the acid side if we eat something poisonous, for example. So buffers are very important. You will have to know this word and the function that it does to our bodies or in any sort of chemical situation, which is that it's going to try to keep pH the same. Okay, that is it for pH. I will see you next time for macromolecules.